Hey everyone, it's John, and today we're going to continue on the BGP video series. So if you remember from the previous video, we had just discussed BGP communities. Now, in that video, we discussed BGP community tags in the form of numerical values, and those numerical values were to correspond to some type of particular routing policy. In this video, however, what I want to discuss is well-known communities. Now, these are what I've written on the right-hand side. We've got 4 of these. The first one is no advertise, the second one is internet, the third is no export, and the last one is local AS. So, what are these well-known communities? Effectively, these well-known communities are tags which you can apply to prefixes to indicate to a receiving router how to propagate that prefix. So think about this, okay, let's say we've got router 4 here, and we tag it with we send a prefix out of all the 4s, 4.4.4.4, and we tag it with no advertise. It will be sent to all of its neighbours, but those neighbours know not to re-advertise that route because it's been tagged with no advertise. That, like it says here, it shares the prefix with the neighbour, but instructs that neighbour to not advertise it to other routers, okay? Now the second one is actually the default setting. This is the internet setting. If you don't put a tag on it, it will automatically act like an internet setting. Now what that does is, as it sounds like, it propagates that route indiscriminately. It will just propagate it out to any neighbour. So if you send it from, example again, router 4, it sends it to all its neighbours. Those neighbours will advertise that route or that prefix to all of their neighbours. Okay, so there's no control there. That's just allowing it to spread completely. Now, 3 and 4 is where the confusion lies. These two are very, very similar, and the only difference comes into play, like it's written down here at the bottom, is when confederations are used. If confederations are not used, no export and local AS act identically. But let's say, like I've got in this topology, we actually do have a confederation in place. No export means that the actual prefix will not be propagated out with the actual AS, okay? So we've got AS33 here. If router 4 propagates a prefix with the tag no export, it will go to this router, this router, this router, and this router because they're all within the same AS, and it will not be exported out of that AS. So this router here in 44 and these 3 in 55 will not receive that prefix because it has been told to not export. Now, local AS. This is almost, to me, a bit of a misnomer. I try to conceptualise this as local sub-AS or local confederation. That's the way to think of it. Now, like I say, if you don't have confederations, it will act like the local AS. It will just stay within the AS. But in this case, we've got 2 confederations. So local AS, think of it as local confederation or local sub-AS. In this case, use the same example again. If router 4 introduces a route into BGP, say 4.4.4.4/32, and it's been tagged with the local AS and it is part of a confederation, the route will propagate to here and to here because they're within the same confederation, but it will not go to this router and this router because they're in a different confederation, even though they're within the same autonomous system. They're in different confederations, so they will not propagate. And likewise, because of that, obviously, by extension, clearly it will not propagate to this router here in AS44 and these 3 in AS55 because they're in completely different ASs. Okay, so that is the basic outline of these 4 well-known communities and the differences in what they can do. So it really is for route propagation, controlling where your routes go, and that is effectively the purpose of well-known communities. Excuse me. So what I'm going to do, I'm going to actually, well, do you know what, let's just start off and do it then, okay? Now, let me just talk about this topology here. What I've done here deliberately, I've actually introduced a route reflector because I want you to see how this actually works with route reflectors. And then on the right hand side, we've just got a basic mesh, as in 9 is paired to 8 and 7, 7 is paired to 9 and 8, and 8 is paired to 7 and 9. Okay, so that's a wee bit different. We don't have a route reflector here. We do on this side. I just want you to see that, how that affects the no advertise well-known community. So let's go and do that just now. So show IP BGP. We've got nothing running in BGP, and I'll just show you the actual BGP configuration. Now remember, when you're doing this, it's important to actually write send community. Remember from the last video when you're doing that. So what I need to do, okay, and we'll do neighbor 3.3.3 send. Oh, let's go into the actual BGP process rather. 65502 and neighbor all the threes, send community. Okay. Now you'll see we're only paired with router 3 here because router 3 is the root reflector. We're not actually paired with 5. Now because of that, when we send a prefix with the no advertise community tag to it, it will not be reflected. Even though you would think all roots will be reflected because we're part of root reflection here, no. With no advertise, it's going to have that tag and the router is going to abide that faithfully. It will just not advertise that root. So let's go and do that just now. That'll be the first one we'll do. We'll do it with a no advertise. So let's create a loopback that we can introduce into BGP. And we'll just call it interface loopback 1 and just do 11, 11, 11, 11. Just keep it quite simple. /32. Oh my god. I'm thinking a prefix list. Let's do the actual subnet mask. Okay. So now we've got our loopback which we're going to introduce. Now what we're going to do is create a prefix list, and we'll just call it list, and we'll permit that. So we're going to identify this route, and let's create a route map. Just call it map per 10, and we're going to match the IP address in the prefix list called list, which is 11, 11, 11, 11. And now we're going to set the community on it. So just do set community, and you'll notice if we do the help, we've got these. We can actually put the tags on it, the numerical tags which we did the last time, but we also have these 4 here: internet, local AS, no advertise, and no export. The one we're going to do first is no advertise, so let's go and do that just now. Okay, so no advertise and do route map. Forgetting the pair 20. Okay, so now I'm going to do router BGP, and we are 65502, and the neighbor is going to be all the threes, and we're going to attach that route map in the outbound direction to it. Okay, now let's introduce that route into BGP. So we'll network all the 11s with the mask of /32, and we'll do a show IP BGP. So we're now injecting this route into BGP. Okay. Now let's see. So the only peer which we have from router 4's point of view is router 3, which is a root reflector. Now we're going to see that it's not going to reflect that route. So show IP BGP, you can see that it has received the route, and if we actually go in and look at this a little bit more detail here, we'll see that it's received it with a community of no advertise, so it's not going to advertise it. Okay, so this router has got it. So let's see if router 5 has it. Enable show IP BGP. It has nothing. It's not received it. And like I say, that is obviously true for all these other routers. Show IP BGP doesn't have it. That's the same with this one. Like I say, the other ASs definitely won't have it. Okay. And just grab one up here just for demonstration. So that was the first well-known community. We introduced a route and we tagged it with the community of no advertise. It's sent to the root reflector, and despite being a root reflector, it is abiding that community tag rigidly and saying I will not advertise that prefix. Now, let's go and do the next one. We're going to do it with the default setting. So if you don't actually put a community tag on it, this will be the default. So you don't need to worry about this one too much, but I'll demonstrate it anyway. So let's go and configure interface loopback 2, we'll call it, and we'll make it all the 22s. Okay, and we'll do an IP prefix system. We'll just call this one list 2, and we'll permit all the 22s /32. And let's go into that route map again. Do route map permit 20 and we'll match the IP address in the prefix list called list2, and we're going to set the community this time to internet, and we'll just put our pair 30 for good practice. And let's go into router BGP 65502 and introduce that route into BGP. Okay, so we do a show IP BGP. We're now injecting two routes. The first one is going to router 3 and it's been told to not advertise it. The second one is going again to router 3, but it's got the internet tag on it, so it's going to propagate freely. Okay, so let's have a look at this. And we'll do show IP BGP, and we have it, show IP BGP 2.2.2, and we can see we have the tag internet community. Okay, so by extension, logically, this one should have it, which it will do. Yep, let's get to 22. Let's get to 22. Yep. Okay, now they're all within the same AS of AS33. Now we'll see that AS44 also has it because it's propagating indiscriminately. And AS55, these routers here will also have it. Okay, so we've advertised two routes out. The first one is being told to not advertise, so it's only went to router 3, and router 3's keeping it in lockdown, not advertising it anywhere. The second one has been tagged with internet, so the second one is propagated to everyone. Now let's look at this case of no export. So like I say, no export and local AS act identically unless confederations are involved, in which case, which we do have. The first one we're going to do is no export. Now no export will keep it within the AS, okay? It doesn't care about the confederations. So let's go and introduce a third route now. So we'll do int loopback 3, and we'll do IP address 333333 and put the same 32 mask on it. We'll do an IP prefix list called list3, and we'll permit all the 33s /32, and let's go back into our route map. Pair 30, and we'll match the IP address in the prefix list called list3, and we're going to set the community to no export. Route map pair 40. Okay, and let's advertise that route into BGP. Okay, so we're now injecting three routes. The first one has got the no advertise, the second one is internet, so it's going everywhere. The third one is being tagged with no export, so it should stay within the AS, but it should go between the confederations. Okay, so let's go. We've advertised it to our neighbour, which is router 3. Let's see what router 3 sees. It sees the three of them, of course, and let's see this new one then. And we have the community of no export. So it's going to advertise it within, to all routers within its AS of AS33. So obviously this router's got it, 33, and you'll see that these two here, because they're within the same AS, will also have it. So let's have a look and see here, 33s, yep, and 33s. But you'll notice it won't be advertised across this link because this neighbour is in a different AS. So this one will not have the 33s. See that? And obviously by extension, routers in this AS clearly will not have this route. Okay, so that is the no export. Let's do the fourth one then. We'll do local AS. So we'll do int loop 4 IP address 444444, and let's put that /32 mask on it. Do an IP prefix list called list4, permit all the 44s, and let's go back into that route map again. Pair 40, match IP address in the prefix list called list4, and let's set the community to local AS. And let's go and introduce that route into BGP. Okay, so that's us injecting four. The first one's no advertise, the second one is internet, the third one is no export, and the last one is local AS, which, like I say, will not propagate outside of the confederation. Okay, so think of it again as local sub AS, which is going to be this little group here, these three. So clearly router 3, our neighbour, will definitely have it. That will have them all. and let's look at the tag on it, and it's local AS this time. So it's going to see and say, you're in my confederation, router 5, so I'll pass it to you. So this will also have it, and it does, but it will not pass it to its confederation peer. So number 2 will not have it. Oh, you see that? And obviously number 1 won't have it. And then very definitely number 6 will not have it. And obviously by extension none in 55 will have it. So that's the basic outline of these 4 well-known communities. Now what I want to do is I want to do the same thing but do it on this one here, because this one we had a root reflector. In this case we're going to have 2 neighbours, so let's go and do the same thing here. We'll do let's just create a loopback called 9 and we'll get all the 99s. Okay. We'll do an IP prefix list called list, permit all the 99s, and do a root map called map again, permit 10, match IP address in the prefix list called list, and we're going to set the community to no advertise. Okay. And root map pair 20. And let's do a router BGP 55, and let's introduce that. Actually, we'll put it to our neighbor first. So our neighbor is, let's say we want to, we'll just advertise it at first then, right? Now, do you know what I'll do actually? Let's try to get the same effect as the first one here, and we'll notice the difference. Okay, so let's try to get the same effect. So we want it to go to this one here, but not go to this one. So we'll do our neighbor, all the 7s, and we'll do a root map out. Okay, and let's inject that into BGP. Okay, so we'll inject it into BGP. Let's just clear that. What have I done here? Made a mistake on that. What am I doing? 99, 99, 99, 99. Show IP prefix list. That's permitted. Show root map list. That should be fine. Hey, don't know why it was taking so long. It was just taking its time. Okay, so as you can see, we have advertised that to BGP, and we've got the community of no advertise. Now you'll notice one thing which I didn't do. If you look at the actual configuration here, I attached the root map outbound to 7, but I didn't do it to router 9. So these routes will automatically get passed to both of our neighbours anyway because we're neighbours. But you'll notice this one will also have it. Okay, but if we do a show IP BGP 99, 99, 99, 99, it doesn't have the community on it. So let's say this router was paired with another router here or whatever. This one would actually propagate it out because it's not got that no advertise, so it's going to default to internet. Do you know what I mean? So what I'm going to do is, how would we advertise that to just this one and not to here? Okay, so what we're going to do is just a prefix list and just filter on it. So let's make another one. We'll do an IP prefix list and just call this one list 2. And what we're going to do is deny the 99. And we'll do an IP prefix list 2, sequence 10, and we'll permit all the zeros. if you don't know about prefix lists, this is effectively me permitting everything. This is like your permit any effectively in your IP, in your access list, sorry. So don't worry too much about this, I'll get to this in another video. Show IP BGP router thingy, and let's do neighbor. So what we're going to do is we've basically identified this route here. So we're saying deny this route but permit anything else. Okay, so we're going to go to our neighbor and we'll do our neighbor 9.9.9 prefix list and just give it the name, and we've got it called list2. And because the route is originating from us, we're going to do it outbound. Okay, so let's do a clear IP BGP soft. And same again here, or rather clear IP. So we do a show IP BGP, we don't have that route anymore, you see that? So it will only go to this router here, and like I say, this router is being instructed to not advertise it, and we're filtering on this router here, so we've now controlled it by just holding it here and using the community tag to say just you have this route. So this other neighbor will not have it because it's been filtered. This one's not going to advertise it, and that's it kept constricted. So I just wanted to add that in at the end just to show you the difference between route reflectors, because we're only paired with one. You don't need to do that obviously in this one because it's only going to go to one, and it's already going to follow the instruction of the community tag to not advertise. In the case of this, once we inject the prefix into BGP using our network command, it's going to go to both routers because we're neighbours. The first one, we'd added the route map, so this was going to have the tag of no advertise. The second one, I didn't add the route map, so it's going to go to here, and if this was connected to anywhere else, it would advertise it out because it doesn't have the information to not advertise it. To stop the route going to there, we therefore added in a prefix list and filtered on that prefix list, so it's only going to here, and it's got the tag of no advertise, so it's going to stay here and not go anywhere else. Okie doke. So that might be a little bit confusing, but like I say, like with all things, just lab this up and you'll see that it's very, very useful, and it really isn't that difficult. The syntax is a little bit odd at first, but by all means just practice, and you'll get there in the end. Okie doke. So that's the end of the video. Thanks very much, and I'll see you guys soon. Bye bye.